All right, hello students. These are the fourth set of AP Stats FRQ Review questions for the 2020 AP test. Start with 2011 number 4. High cholesterol levels in people can be reduced by exercise, diet, and medication. 20 middle-aged males with cholesterol readings between 220 and 240 milligrams per deciliter of blood were randomly selected from the population of such male patients at a large local hospital. 10 of the 20 males were randomly assigned to Group A, advised on appropriate exercise and diet, and also received a placebo. The other 10 males were assigned to Group B, received the same advice on appropriate exercise and diet, but received a drug intended to reduce cholesterol instead of a placebo. After 3 months, post-treatment cholesterol readings were taken for all 20 males and compared to pre-treatment cholesterol readings. Tables below give the reduction in cholesterol level, pre-treatment reading minus post-treatment reading for each male in the study. In other words, the positive number will tell you what the reduction in cholesterol is. It's a good number. Do the data provide convincing evidence at alpha equals 0.01 level that the cholesterol drug is effective in producing a reduction in mean cholesterol level beyond that produced by exercise and diet? So let's take a look at the steps. Step 1 is to state your parameters, the population of interest, and choose your procedure and your hypothesis. So mu1 is the true mean reduction in cholesterol for middle-aged males with exercise and diet while taking placebo. Mu2 is the same, but for those taking a drug. This is a two-sample t-test for mu1 minus mu2. You have two independent groups because of the random assignment for an experiment. So the null hypothesis is that mu1 equals mu2. There is no difference in the cholesterol reduction in the two groups, whether the patients took a placebo or a drug. Alternatively, mu1 is less than mu2. We expect a greater reduction for the drug group or a lesser reduction with the placebo group. So the alternative is mu1 is less than mu2. Step 2, we'll look at the conditions. First, the random condition. We were told that the 20 men were randomly assigned to either Group A or Group B. For the normal condition, because each sample size is 10, you have to include some graphs, so I included the normal probability plots. For Group A, which is the one on the top, it looks pretty linear. For Group B, there might be an outlier at the bottom left, which was that negative number, but the T procedure should be pretty safe to use. So again, if you have a sample size below 30 and the data, you need to include a graph. Now, of course, in the 2020 test, you don't have to include a graph because there are no graphs, but normally you would. Here are the histograms. Group A shows you a slightly skewed right distribution, but for Group B, it's roughly symmetrical. Again, we can approximate normality. So again, you need to include some sort of visual evidence. I should mention that there's no need to check the independent condition because it is presumed that the two randomly assigned groups are independent. Now let's move to the calculations. The t statistic is x bar 1 minus x bar 2 over the square root of s1 squared over n1 plus s2 squared over n2. Conveniently, they gave you all these values. You didn't even have to use the calculator. So 10.20 minus 16.40 over the square root of 7.66 squared over 10 plus 9.40 squared over 10 yields a t statistic of negative 1.618, which corresponds to a p-value of 0.062 with 17.3 degrees of freedom. Do not forget to write the degrees of freedom from your calculator. So with the p-value of 0.062, that is not less than alpha equals 0.01, so we failed to reject the null hypothesis. There is insufficient evidence that the drug is effective in producing a mean cholesterol reduction beyond that provided by exercise and diet alone. So there might be some evidence, but it's not strong enough at the alpha equals 0.01 level. 2019 number 1. The sizes in square feet of the 20 rooms in a student residence hall at a certain university are summarized in the following histogram. Based on the histogram, write a few sentences describing the distribution of room size in the residence hall. So now you're basically going to look at shape, outlier, center, spread. So let's look at the shape first. The shape is bimodal. In other words, there are two peaks and it is roughly symmetric with two clusters, one from 100 to 200 square feet and another cluster from 250 to 350 square feet. Now the center of the distribution is going to be between 200 and 300 square feet, somewhere in that neighborhood. You could have said 200 to 250 and that's totally fine. For range or spread, it could be as wide as 100 to 300 if you look at the extremes of the histogram intervals, or it could be as narrow as 150 to 300. So that's the range or the spread. There do not appear to be any apparent outliers, but you may not be able to see them anyway because of the histogram. Part B, determine whether there are potential outliers in the data. So now that we actually have the statistics, we can find out. So for the IQR, we need to look at 292, which is Q3, minus Q1, which is 174, or 118. So for value to be an outlier, it's got to be at least 1.5 times the IQR above Q3 or below Q1. So for the upper limit, it's 292 plus 1.5 times 118, which means a value has to be at least 469 to be considered an outlier. On the lower end, it's 174 minus 1.5 times 118, which comes out to -3. So you can't have a negative or low outlier. So there are no outliers as no room size is greater than 469 square feet. Now we're going to draw a box plot of room size with the new numbers. We see the Q1 is at 174, median's at 253.5, Q3 is at 292. Draw the whiskers to the minimum and maximum values. So the minimum is 134, the maximum is 315. Part C, what characteristic of the shape of the distribution of room size is apparent from the histogram but not from the box plot? So the box plot cannot determine the shape of a distribution alone. So notice that the histogram tells you it's a bimodal distribution. It's got two peaks, but the box plot cannot tell you that. As far as you can tell, it looks slightly skewed left. So that is not apparent in the box plot. So once again, a box plot cannot be solely used to determine the shape of a distribution. 2014, number 5, a researcher conducted a study to investigate whether local car dealers tend to charge women more than men from the same car model. Using information from the county tax collector's records, the researcher randomly selected one man and one woman from among everyone who had purchased the same model of an identically equipped car from the same dealer. The process was repeated for a total of 8 randomly selected car models. So the question is, do the data provide convincing evidence that on average women pay more than men in the county for the same car model? So you have some summary statistics for women, for men, and the difference. We also have dot plots for the women and the men, and a dot plot for the difference in purchase price, the women's price minus the man's price. So step 1, identify the parameter and choose a procedure. This is going to be a matched pairs procedure, where mu of the difference, or mu, equals the true mean difference in purchase price. And since the figures they gave you were the women's price minus the man's price, we'll just use that. This is a one sample paired t-test for mu. The null hypothesis is that there is no difference in the purchase price between women and men. Alternatively, we believe that women are paying a higher price than men for the same car at the same dealer. So the mu is greater than 0 for the alternative. Conditions for the procedure. Let's start with the random condition. The car models are randomly selected from all the different car models. The normal condition. So the dot plot of the sample price, again, we're looking at the list of differences, reveals a roughly symmetric distribution. So there's nothing indicating that it's asymmetric. It's not like all clustered on one side or the other. It's pretty well evenly spread out. So we'll consider this distribution approximately normal. Finally, independent, it's matched pairs. So we have to state that the observed difference in the purchase prices for each model are independent. So even though within each model they are not independent, across different models, the differences in the purchase price are independent. Let's move to the calculations. So we are going to use this. We are not going to use the men and the women's mean and standard deviations. If you did a 2-sample procedure, you would have used those. You would have also been wrong. So the DF is 7 because the sample size is 8. Alpha is 0.05. So the t statistic is x bar minus the null value divided by s of x over the square root of n. So the mean difference was 585 minus the null value of 0 divided by s of x, which is 530.71, divided by the square root of 8, yields a t statistic of 3.12 and a p-value of 0.00845. Now that p-value is much less than 0.05, so we reject the null in favor of the alternative. There's convincing evidence that on average, women pay more than men in the county for the same car model. That's it for this set of review questions. If you have any questions, feel free to ask me.